So let's understand this concept, please. I'm doing the record because people don't know this topic. So let's say, for instance, we're all 100% in Java Tech. Maximum 80% don't know it. So they find it difficult. So that's why I want to do the record as I'm teaching you guys at the same time. So after class, I'll thank you. You understand, you understand. All right, let's start, please. Definition. Let's start with mathematical induction. Let's start with mathematical induction. By definition, mathematical induction is simply a method. Mathematical induction is simply a method used. By the way, we'll solve past question, please. I have a past question with me. So after I think there are 4 questions there. So after the class, I'll give some example. Then we'll look at past questions, right? It's coming out to please. All right. I said mathematical induction can be defined as what? I want to say it's simply the method of what used to show. By the way, mathematical induction is simply a method used in mathematics. Mathematical induction is simply a method used in mathematics to prove mathematical equation or expression or statement. Mathematical induction is a method used in mathematics to prove mathematical equation or mathematical expression or mathematical statement. Anyone want to? That's your definition for mathematical induction. When it comes to solving problems under mathematical induction, there are 3 rules there. Rule 1 is what? Let n to be k, sorry, let n to be 1. Rule 2, n is what? K. Rule 3, n is what? K plus 1. That's so. By the way, let me give you. So, please, let's look at the steps involved in solving mathematical induction. Let's look at the steps involved in the study of mathematical induction. There are 3 steps in solving mathematical induction. There are 3 steps in solving mathematical induction. Number 1 there is called the first step is what? To let n to be equal to 1. This man is called the basic rule. This man here is called basic rule. We said there are steps in solving mathematical induction. The first step is what? Let n to be equal to what? Equal to 1. So I said when it comes to mathematical induction, there are 3 steps there. Step 1 says let n to be what? Equal to 1. So we call this what? The basic rule. Now after making your n equal to 1, you look at your left hand side. If it's equal to what? Your right hand side. Don't worry, you understand this. The step 2 is called the induction step. Let n to be equal to k. This is called what? The induction step. So we said there are 3 steps. Step 1 is what? Let n to be equal to 1. It's called the basic step. So you check your right hand side. If it's equal to the left hand side. Step 2 is what? Let n to what? K. Now, mind you, when it comes to this step 2, we always assume that it is true. I'll show you what I mean by this. So when it comes to your step 2, always assume that n equal to k is what? Is true. Are we there? Let's look at the 3rd step there involved in solving mathematical induction. Oh, sorry. All right. The 3rd step there is to let n to be equal to k plus 1. So these are like the 3 steps involved in the study of mathematical induction. When you see a question, first task, let n to be 1. After putting n as 1, you check your left hand side. If it's equal to your right hand side, then you got the same thing. Then you proceed to what? To your next step. Let n to be what? K. You put k as n. Then finally, let n to be what? K plus 1. We'll look at this concept using some several examples. Let's look at example 1, please. Example 1. Let's start with example 1. Example 1. Prove that for all n, which is an element of a natural number. I have question 1. Question A now is given to be 1 plus 3 plus 5 plus dot 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 plus into 2n minus 1 equal to n squared. All right, this is the first question, please. Let's try to prove this expression here. Okay, this n, this element e, this means for all n, all this n you are seeing, for all n, what is an element of a natural number. N means natural number. By the way, natural number, we mean what? Our normal number 1, 2, 3, 4. Those are not what? Natural numbers. Are you there now? So it means that I'm going to be having my answers in terms of what? Natural numbers. Are you there? All right, let's prove this identity, please. Let's start with this. We said, this is my question here. I'm taught to prove this man here. We said, your first task when it comes to proving, what's the condition? There are 3 conditions there. What's the first step? Let n be what? 1. So my first step here now is that. Exactly. So look up now. Let n to be equal to 1. I believe that's the first condition. All right. This is my what? First condition, Abi. So it means that looking at my left hand side, this is my left hand side, Abi. It's only this one that has n in it, Abi. It's only this man that has n in it, Abi. Bring it out. That becomes 2n minus 1. True or false, Abi? Is equal to, we said anyway you see n, put 1. That becomes 2 into 1 minus 1. What do I get here? 2 minus 1. What's my answer there? My left hand side gives 1. Let's now look at the right hand side. Of course, this is my right hand side, Abi. Yes. So from here now, my right hand side now, right hand side. What do I get? That's what? N squared, which is what? 1 squared, which will give 1. Observe that my left hand side is equal to right hand side. Proved. This is proved. That's your step 1. If it's not, let's say assume that this is 1. This left hand side is 1. Right hand side is 2. Then they are not what? The same. Hey, they're not. If this one is, if my left hand is 1, right hand is 2, they're not the same thing. Hence, you can't proceed to the next step. But since they're the same now, 1, 1, Abi, so we can what? Proceed to the what? Next step. What's the next step? Huh? No, you said let n, just only n. We didn't say 1. We didn't say 3. We said let n to be equal to 1. So anywhere I see n, I'll put 1. So looking at it, this is my left hand side now. Pick one that has n. This one that has n, Abi. This term here. That has n. This one, bring it here because it's my left hand side here. So my right hand side. Are you there? So pick out this down, then put n as 1, which is this. You have 1. This is my right hand side equation. Bring this one here, then put n as 1. That's 1 squared, which is we give 1. So that's my first task. Okay. This is 2n minus 1.
That 1 in that bracket, how do you use to multiply that 2? Yes.
We said n should be 1. Abi? 2n means 2 times n. 2n means 2 times n. That becomes 2. Into what's this value for n? That's 1 minus 1. 2 times 2 is 2. Then a minus this 1. That's this 1, please. This is your first step. What's the next step? We said let n to be what? K. Are we there? So next step now, let n to be what? K. And we said we should assume that is what? Is true. All right. So from there, go back to your question. I have what? 1 plus what? 3 plus 5. Plus dot dot dot. Plus what there? 2k. Listen up. We said let n to be what? K. That becomes what there? 2k minus 1. Are you there? Equal to what there? K squared. We said, observe that left hand side is not equal to what right hand side, Abi? I mean, are they the same thing? No, but we said assume to what? To be true. Assumption, please. So I'm done with this first step, second step. Let's look at third step and we're off. For the third step, we said let n to be what? K plus 1. This is where the issue comes in. Now listen up very well. For your k plus 1, are you listening to me? What do you write out? Here's what you write out. Oh, listen. Go back to your assumption equation, which is this one. We said we assume that this is true. Copy this one down first. When it comes to k plus 1, when it comes to substituting k plus 1, we said your first task is go back to your assumption. Drop this man back first. So I'll have what? 1 plus 3 plus 5 plus dot 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 plus into 2k minus 1. Abi, listen up. Oh. Don't write this one. Oh. Drop this one down first. When you are done, go back to your original question, which is this. Are you there? Which one has n? This one has n, Abi. So I'll put the value of n as what? K plus 1. So this is a plus. So I'll have a plus sign here into, this is 2k, 2n, Abi. That becomes, so I'll have something like this. 2 into k plus 1. Abi now? Next up, minus 1. Are we there? Is now equal to, this is what? N is what? K plus 1, Abi. That becomes k plus 1 all squared. Let me explain again. It's confusing when it comes to k plus 1. For k plus 1, what you have in the assumption, drop it down first. I have this one. When you are done dropping it down, go back to your original question. I'm having from here down here, I'm having n's there. Abi, put a plus, that's the plus sign there. Into this is 2. This is the 2 here, right? N is this, and we said n should be what? K plus 1. So put k plus 1 here. Then that minus 1 is this man here. Equal to what? N squared. That's what? K plus 1 squared. Now let's prove our left hand side now being equal to right hand side, and we are off. How do you do that? Note that, listen up, open your eyes well. Note that from this point here, observe down here, listen up, listen up, listen up. From this point here, down here, is what our Abi. And what's the value? Substitute what? Everything has what? K squared. Do you get? What I'm having here from here to here is what is here, Abi. And what's the value? K squared. So replace this one as what? As k squared. So I'll have what there? K squared, which is this plus what? Plus into what? 2 into k plus 1 minus 1 equal to what? K plus 1 all squared. Very good, please. Are we there? Yes. Now, what's your next task? I'll make sure that my equation of right hand side must equal to what? Left hand side. So I'll work on them, I'll simplify them. So what do I get here? I'll have k squared plus into 2 times k. 2k plus 2 times 1. 2 minus 1. I'm done with this. Is not equal to, this one means k plus 1 into what there? K plus 1. True or false? True. What do I have here? I'll have that k squared plus into, listen, look at the way I'm using my square bracket and round bracket. Listen up, I'm not combining like this now. Look at, let's say I have, look at 2n now, 2n minus 1. Let's say I'm going to substitute 2n as k plus 1 now. Now I'll be having, observe, I'll have 2n minus 1. They say we should put n as k plus 1. I'll have 2 into k plus 1. Are you there? Observe, this one is here, Abi. So this is bracket, this is bracket here. 2. This one is k plus 1, Abi. Minus 1 this way. See, it's not making sense like this. It's correct, but it's not proper in mathematics. So if you're having a round bracket inside, use a what? A square bracket. Even it look more mature like this compared to the way I did it before. So let's say you're having under bracket a square bracket like this. You can use what? A cone bracket is also higher than square bracket. So the more you are seeing the bracket, the more you advance in your use of brackets. So mind the way you use your bracket. Are you there now? So I can't come and say round bracket, round bracket. It will not look exactly. So it's not allowed in mathematics that way. So use a square bracket and a what? Round bracket. So round bracket is small, square bracket is what? The next to round bracket. While cone bracket to yes, that's how it works. Please. So that's how it works. So from here now, what do I get? Listen up. 2k becomes my 2k. 2 plus 2 minus 1 is what? Please, is it my phone that's doing ton? Okay, so that's plus 1 abi plus 1 abi equal to expand is using binomial theorem. Abi now I taught you that last class, binomial theorem. So pick out the first term k into everything here is what? K plus 1. What's second term here? Plus 1 into everything here k plus 1. What do we get here? I'll have that k squared plus, remove the bracket, that becomes 2k plus 1 is equal to expand k squared plus k plus 1. True or false? Let's done. I'll have that k squared plus 2k plus 1 is equal to, sorry. All right, so I have plus 1 here is equal to what? K squared plus 2k plus 1. Observe that my left hand side is equal to right hand side. So this means that therefore the mathematical statement is true. So I have this, please. So I have this. Understand?
Yes, sir.
Copy down, please. Let's do number 2 to explain it more better. So the task is quite simple. Start with your rule 1. Is this recording?
Yes, sir.
All right. We said start with rule 1. Let n to be 1. This is my question. Put n as 1 first. Left hand side equal to right hand side. No problem. So at this point now, your second step is what? Let n to be k. Pick out a question back. This question back there. Anyway, see n, put k. Now, we said for your k to be, so for your n to be equal to k plus 1, we said repeat your assumption from here to here. Repeat it down first. Now go back to original question. From here down here are n. I'm seeing n here. Abi, start with this plus. This is the plus here. Every expression here is what I have here. So, but put n as what? K plus 1 is now equal to n squared. What's n squared? K plus 1 squared. From there, simplify. Observe that my left hand side is equal to right hand side. So it means that the mathematical statement is what? Is true. Let's do example 2 to further explain this concept. Everything, Abi? Okay. Yeah. All right. Are we ready? Let's do example 2. Listen up. Let's do example 2. Let's prove this man here that n is an element of what? Natural number, right? Let's prove this, please. We said when it comes to mathematical induction, what's the first task? Your first step is what? To let n to be what? Equal to 1. So apply your basic steps. So we said let n to be equal to what? 1. If n is 1, what do I get here? My left hand side is equal to what? This one, Abi, into 4n minus 1. True or false? True. Is equal to, anyway, see n, you should put there 1. That becomes 4 into 1 minus 1. This gives what there? 4 minus 1. What answer there? 3. No problem. I have 3 there. Also, we said for your right hand side, do the same thing. So that becomes my right hand side is equal to, I have n into 2n plus 1 is equal to, we said anyway, see n, put what? 1. So I have what? 1 into 2 into 1 plus 1. Mind you, I'll use what? A square bracket because I'm seeing number inside. So for me, I'll have that this 1 here, sorry, into 2 times 1 is what? 2 plus 1. That gives what there? 1 into 3, which will give what there? Observe that my left hand side is equal to my right hand side. So hence, left hand side equal to right hand side. Now let me emphasize on something. Let me explain something. Look up. Check your previous example with this one now. Always note that whenever you say let n to be 1, that answer will be having 3 will be the first thing that will come in your question. This 3 here. Check your other example. Check the answer you have and check what begin that thing. What's it? It's still 1. So the expression, the first term here gives you what you are expecting. So if this one is 3 over 4, 3 over 4, therefore it should be what? 3 over 4. That's your guess. So if you're having, let's say we solve them, we're having 10, 10, and this one is 3, you are wrong. So anyway, whenever it's let k to be 1, let n to be 1, so let n to be 1, always ensure that the value here is always probably always equal to what? Left hand side and what? Right hand side, please. So that's your task here. Now, what after? Listen up, listen up, listen up. Shall I continue? Yes. At this point now, what's my next thing? Let n to be what? K, and we should what? Assume that is what? Correct. So at this point now, we said let n to be what? K. Are we there? Yes. Please, I'm making noise. Sorry. Please. Yeah. Let's proceed. Let's proceed. All right. We said let n to be what to K, Abi? Go back to your question there. I have what? 3 plus what? 7 plus 11 plus plus into 4n. We said h should be what? 4. Sorry, k rather. Abi minus 1 is equal to what there? K into 2k plus 1. I have this one here. So now we said what's the next task? We said assume this is what? Correct. Abi now? We said assume that it is what? True. So after applying your induction step now, what your next task? Let n to be what? K plus 1. So at this point now, let n to be what? K plus 1. Copy down. Let me fill this thing. All right. We said first things first, when you see a question under induction, what's your first priority? You should let n to be what? 1, which is what? Your basic rule. Abi, put 1 as being your left and your right. Ensure that what? They are the same thing. When you are done with this, second step says what? Let n to be what? K. That's your induction step, right? So my n now is k. I have this expression here. We said last step is what? We said let n to be what? K plus 1. Mind you, for the previous example, I said whenever you say let n to be k plus 1, what's your first task? Repeat your what? Assumption expression down first. So now there. All right, that becomes what there? 3 plus 7 plus 11 plus plus what there? Into 4k minus 1. True or false? We said do not repeat this one. No, just repeat from here to here. Are we there? Is this? Go back to your what? Your question. From here now downwards. So that becomes what there? Plus observe 4. Observe into what there? N is what? K plus 1. Next stop minus 1. I have this one. Abi is equal to what's your n there? K plus 1. That is this n here. So into 2 into what there? K plus 1 plus 1. Sorry. Observe the use of what? My bracket, please. All right. At this point now, what's your next task? We said observe that from here to here. Okay. We said at this point now, after putting your k as what? Sorry, after putting your n as what? K plus 1. What's the next task? We said from here down here, we give what? K into 2k plus 1. True or false? So we said go back to this man from here down to what? This point. We give you this man. Put this man here now. I'll have what? K into 2k plus 1. I'm done with this, Abi. Then go back to this man plus into 4 into k plus 1 minus 1. Are you there? Is now equal to what? K plus 1 into 2k plus 2. 2 times k, 2k, 2 times 1, 2. Next up, plus 1. I have this one here. What's the next task here? Simplify such that your left hand side will what? Equal to right hand side. What do we get here? Use this case to expand through. I'll have 2k squared. Abi? K times k, k squared. Abi? With this 2 there, plus what? K plus into 4k plus 1 minus 1. Hang on. Plus, Abi? 4 times k, 4k plus, okay, thank you. Is 4. 4 times 1 is 4. Listen up. 2k times k, that's 2k squared. Plus k times 1, k, no problem. Plus k times 4 times k is 4k. Plus 4 times 1 is 4 minus 1 is now equal to what I get here? K plus 1 into what there? 2k plus 3. True or false? Yes, true. Let's simplify what I get. I'll have 2k squared plus what there? Remove the bracket. I'll have there plus k plus 4k plus 4 minus 1. True or false? Is now equal to, we said expand this man. Abi? Expand what? So I have k into 2k plus 3. Am I right? Pick out the first term into everything here. Plus 1 into what there? 2k plus 3. Are we there? What do I get here? Should proceed? All right. This one? Yeah, Abi. You now use negative to expand. Yes. Listen up. If I have a negative sign here, I must use the negative sign to expand through the bracket. Are you there now? But since it's positive, just drop it down the way it is, please. All right. At this point now, what do we get? This becomes 2k squared plus what? 5k plus what? 3. Are we there? Is now equal to expand through 2k squared plus 3k plus 2k plus 3. Add up 3 and 2, 5k, the same thing. So have that 2k squared plus 5k plus 3 is equal to what? 2k squared plus 5k plus 3. What do you observe here? So what do you observe there? My left hand side equal to what? Right hand side. So therefore, the mathematical statement is true. Copy down, please.
So, sir, like this now, if the person wish to like add them together again, let's say 5k plus.
No, add them again. It's not able. You want it like this now. You can add it. So you just leave it. Always leave your left hand side and right hand side. Just solve it together. Don't combine them. Make this one individual. This one to individual. So at the end of the day, you see that they are comparable. I have the answer here. Okay. Where? This one, Abi? This part? Yeah, Abi? You see the same thing now. You put k here first. Minus plus 1, you bring minus 1 here. Now it's minus 1 to expand this one. That's minus 1 times 2k, minus 2k. Instead of 2k, be minus 2k. So I have this. So this becomes your idea behind mathematical induction. Let's do example 3. So we'll look at now higher concept. All right.
What's it called? That food. I use your answer. That's what it was. We use.